Today I'm going to be answering a question sent to me by a student, chapter 7, about 2x2 contingency tables, meaning 2 rows and 2 columns, which is specifically homework number 12. This is the data, and this time I'm going to be doing it in StatCrunch, which is quite easy in these particular cases. The first step is to recognize that you're going to go into Stat, Tables. This is an example of a contingency table, how one variable depends upon another. Contingency means depends upon, one of its meanings. And here we have a summary. We don't have the actual 53 rows of data, we have only a summary. And after much experimentation, I believe you put in row 2 and row 3, and here you put in row 1. We're going to need eventually something called the expected count, and we will be doing a chi-square test for independence. That's already chosen for us. So you merely hit compute, and you have all the relevant numbers. So it says, find the part A, write the hypotheses. Well, usually, I guess the choices are independent, dependent, but usually the H0 is that they're independent, meaning there's no relationship. That's why it's called a null, meaning nothing's happening, hypothesis. And the H1, called the alternative hypothesis or the research hypothesis, is that there is some evidence that the data are related to each other, or one depends upon the other. That's the correct answer for part A. Part B, find the expected frequencies. Well, they're given to us in this part of the table in parentheses, and you just type them in. So I did that before to save time. And finally, the chi-square statistic is also given to us as 8.10. Really 8.11, but let's do 8.11, but would mark it correctly either way. Find the chi-squared critical value. Well, here we have to go to a different part of StatCrunch. Let's go back to StatCrunch. I'm sorry, we also going to need at some point the p-value. So remember the number 0044. Keep that in mind. I don't have to remember it. Okay, let's go back. Let's get out of this. Stat. Now we're going to go into, we want to figure out the critical value. And again, I am always apologizing because if I was teaching this from scratch, I would lecture for this for about an hour, but those lectures are found on the YouTube videos that I made on all these relevant chapters. About chi-square, for example, a few videos about the concept of independence and how the formula works, etc. But we want right now, chi-square calculator. This pops up. If you recall, there was 1 degree of freedom in this example, and it's really the number of rows minus 1 times the number of columns minus 1, so it's 2 minus 1 times 2 minus 1, or 1 times 1, or 1. We want this to be 95%. Remember, the alpha is 0.05. That means we want a 95% chance that whatever this number is less than that number. And so you hit compute, and the answer is 3.84. It means there's a 95% chance that under the null hypothesis, there's no relationship, but of course data is always moving around randomly. Is a 95% chance will be just by luck be lower than 3.84. So 3.84 is the critical value. Answer. Good. P-value, I told you before, we had that other 0.0044. Okay, and now comes the interpretation. The test statistic, which was 8.11, exceeds the 3.84. We're in the reject region, and the p-value, another way of doing this, is less than the 0.05 of 0.0044. So either of those two would therefore argue to reject the null hypothesis and conclude that the two of them are not independent, they're very likely dependent. Answer, good, and we're done. Hope to help.